All right, recording going, screen share going. We're ready to start the show. Happy Thursday. We've almost made it through another week and almost the first half of the semester. Has it gone fast or slow? So fast. So fast? We got, all three of you agree fast in the room here? Zoomers, what's your take? Fast or slow for the first half of the semester?
It's been pretty fast.
Pretty fast, okay, yeah. Well, I hope that everybody gets a chance during spring break to take a little bit of a breath, I would say, even if you can't go anywhere fun, which I wouldn't recommend, given how expensive and challenging it can be to travel during the 1 week everyone's out of town. Hopefully you can at least catch up on sleep or laundry or, otherwise reset for the rest of our time. But speaking of resetting, what we have to finish up in example 2b is nominal models. So big picture, what are nominal models for? What kind of outcomes? Who wants to tell me or type to me? What's nominal models for?
Those are different categories that don't have an order.
Yeah, for predicting categorical outcomes that do not have an order. Could you use a nominal model for an outcome that does have an order?
No.
You could, actually. Would you want to is a different question. Yeah. So it works asymmetrically. If you have a nominal outcome, you could not predict it using an ordinal model because it wouldn't make sense. Whereas if you have an ordinal outcome, you could predict it with a nominal model if you care about each of the categories separately. So nominal models, I think, are a little bit more straightforward with respect to what's being predicted, and there's no worry about violating proportional odds because they don't make that assumption. By default, when you set up a nominal model, all submodels have separate intercepts and separate slopes. So everything is estimated separately. So I am using the same ordinal outcome of likelihood of applying to graduate school to demonstrate nominal models because I can. And furthermore, because this one only has 3 categories, it actually ends up being equivalent to an adjacent category model as well, because I'm going to pick the middle category to be the reference. So we have 0 equals no, 1 equals maybe, and 2 equals yes for our outcome. I'm going to pick the middle one, maybe, as the reference category, and then predict the logit of saying no instead of maybe, or yes instead of maybe, which works out to the 2 adjacent differences. So you can use nominal models for ordinal outcomes if you're interested in the likelihood of each individual category. If there are lots of categories and you don't really care about each individual one, you just want to know about predicting more or less of a response, then ordinal is probably a better bet. So synonyms for nominal, these same types of regression models are called multinomial models, which is sort of a silly name because all of these use the same multinomial distribution. The type of link function that we're going to use is what's known as either a baseline category logit or a generalized logit. So if you see those words, they all mean the same thing. And as I mentioned, I think before, there is an alternative way to code nominal models rather than this dummy coding outcome version, but that way is way more confusing. And so I'm not going to go into that for our purposes. It's used in IRT models, though. Okay, so we ready to do this? Ready as we're going to be, anyway? All right. Oh, people still arriving. All right, no worries. So I'm starting with an empty model. For the same reasons that I'm starting with an empty model for the other models, I'm trying to figure out what is being predicted. And in this case, there is an inconsistency in the output that makes it potentially confusing and less obvious what is happening. So I want to make sure that I describe that inconsistency as well. So we are starting off with SAS and then Stata and then R. In SAS, I'm back to using Glimix. You can use a couple different routines in SAS to do nominal models, but this one generalizes to multivariate models as well. So the outcome variable that I'm predicting is this apply 3. It's the same one that we have. It's 0, 1, or 2. And I have chosen the middle category, answer 1, that corresponds, let's say, to maybe or as the reference. So the first submodel for my 3 outcomes is predicting the logit of answering 0, meaning no, instead of maybe, given that you've answered one of those 2 categories. So the first submodel narrows down from the choice of 1 as the reference, and then what is the logit of picking 0 instead of 1. So it's moving backwards in the scale. And the second submodel then still has 1 as the reference, but it is predicting the logit of answering 2 instead of 1. Okay. So then in Glimix, you have to tell it what your reference is. And the way that SAS does this is that it wants to know specifically which answer is the reference. So you could have a string variable in here in which you have words instead of numbers, and it will still take it. But 1 is the reference category that I've chosen for this. We still have the same denominator degrees of freedom being turned off, so the results match across programs. Link equals G logit. Any guesses as to what the G is for?
Generalized.
Generalized. Yeah, the name of the class. That word gets used a lot. So it's G logit, and what would it have meant if I typed C logit instead? That's cumulative. Now, in this one case of an empty model, there would actually be equivalent, because a cumulative model would have 2 intercepts, and this model has 2 intercepts, and so in terms of the likelihood and the predicted probabilities, they would be exactly the same. But that equivalence would break down once we start adding predictors. Distribution equals mult. What does that stand for?
Multinomial.
Multinomial. Now, is this something that I have to worry about for categorical outcomes, whether or not I've chosen the right distribution?
Didn't you just say there was one?
I didn't just say that. Yeah, I'm going for a review, but yes, I did give the answer away. Yes. Yeah, there's only one. So if you have binary outcomes, it's Bernoulli, the end. If you have categorical outcomes, it's multinomial, the end. And that's nice and comforting for now. But starting from 20 minutes from now, that's not going to be the case. So we can decide on which type of link function is most appropriate based on the type of research question you have about your categories, whether or not the categories are ordered, and then logit versus log-log or complementary log-log has to do with asymmetry in the responses, but the distribution for these models is always going to be the same. Not a coincidence, your next formative assessment is available, and there may or may not be a question that I just answered on it related to this topic. So that will be due on Monday. So I am going to ask for the intercept with an estimate statement as usual so that I can get the predicted probabilities. And here's a new option for us, ByCat. So this is specific to nominal models. It spits out the probability for both of the submodels simultaneously. So you don't have to ask for one versus the other like we did in the ordinal ones. Okay, I'm going to skip the output for just a second to show what it looks like in the other packages, because there's an important thing that's easy to get confused. So the next page is Stata, and I'm using mlogit, which stands for multinomial logit. Base outcome is the command that allows you to decide which outcome is the reference, and it is also 1. So I'm choosing, of the 0, 1, 2 possibilities, I'm choosing outcome 1 as the base, and then margins is going to give me all 3 probabilities. Then we get to R. So I'm still using the vglm package. It does a lot of different things. The vgam package has a whole ton of stuff. A lot of it is very difficult, I would say, to wade through, but this took me a minute to get right, so I want to make a point. Ref level equals 2, because according to R, option answer number 1 is the second choice. I know, So it's doing this as an index of counting from 1, 2, 3. So ref level equals 2 actually refers to answer choice 1, given how I've coded the variable. In your homework, I have set it up to be 1, 2, 3 to try and avoid this potential confusion, but I wanted to make a note of that. So this is the one that looks a little different. Family equals multinomial, turns on the nominal option. Reverse equals true, make sure that I get intercepts instead of thresholds. And this is just an empty model with only an intercept in it. Okay. So category 1 is the reference. So each of the submodels is going to tell me the logit of answering the other category, given that the answer was one of those two possibilities. So in SAS, for instance, I'm back on page 18. Under parameter estimates here, my intercept for the first submodel, which is labeled 0. Anyone want to try to interpret that number right there, the 0.4520? I'm listening and I'm watching the chat window. Go for it.
I would say that that number is the log of the odds or the probability of a 1 instead of 0, holding all the attributes equal 0.
It is, so there's no predictors yet, so we don't have to worry about holding them yet.
Sorry.
But yes, but that's correct. So this one, so the reference category is a 1. So this is the logit, the log of the odds of the probability of answering 0 instead of 1. Because 1 is the reference. And the second submodel is the same idea, but now it's 2 instead of 1. So conceptually, this model is like we've dummy coded our outcome variable, and we've decided that the answer category 1 is the reference, and so the model is talking about moving off of that reference to another answer choice. So the logit of answering 2 instead of 1 is minus 1.2528. The logit of answering 0 instead of 1 is 0.4520. And then if we go down to the probabilities here that are usually given by the I inverse link function, they don't match. A logit of 0.45 does not correspond to a probability of 0.55. And a logit of minus 1.2 does not correspond to a probability of 0.1. So then the next logical question is, okay, so what the hell is that? Here is what it did. SAS tried to help you, but I find it confusing. So here's how we get those numbers. Let's see if I can get it all on one thing here. So if I start with the interpretation of the submodel, given that they answered 0 or 1, what is the probability that they answered 0? That's my logit. That translates into a probability of 0.66. That probability is the amount, or let's go with proportion of people in the 0 category over the proportion of people in the 0 or 1 categories combined. So 0.611 is the probability of answering 0 instead of 1. What SAS did is go ahead and lump back in the other possibility of answering 2 to give you the marginal probability instead of the conditional probability. So conditional probability is, given that it's 0 or 1, what's the probability it was 0? So the given that part subsets the data into only those 2 answers, and the model is predicting the logit of a 0 instead of a 1. But the marginal probability, once you add the people who answered 2 back in, works out to be the correct probability of people who answered 0 out of any choice. So these numbers here do not match because they're trying to help you get back to your original question, which is, what is the probability of answering 0? It's 0.55. But the roundabout way we get there is through a series of conditional probabilities. Likewise, given that somebody answered 2 or 1, the logit that goes with that, the logit of answering 2 instead of 1, translates into a probability of 0.22, because that's what a proportion of 0.1 over 0.1 plus 0.35 is. So these are marginal probabilities. That's what I want to say, even though these logits are conditional within each submodel. And I have an Excel sheet, by the way, in which I've worked out all of these numbers for you, so that hopefully you can have that to refer to. So the logit that corresponds to, the probability that corresponds to the module logit is based on only those two, but then the marginal probability is based on all three. Okay, how are we doing with that concept?
I think I get the marginal piece. Can you talk through the conditional piece again?
Yep. So these numbers are not only on different scales, they are talking about different things. So this number over here is a logit, and it is a logit in a world in which 0 and 1 are the only possibilities.
Got it, okay.
Whereas this,
Ignore category 2.
yes, yes. Whereas this probability is acknowledging that a 2 is also possible. And so out of like sum to 1, what is the probability of answering 0, including the 2's?
And because this is an empty means model, that mean is going to line up with the percentage distribution.
Yes, yes.
Like frequency stuff, okay.
Yep, and so because this is an empty model, you should, at the end of this process, get back the exact probabilities of each of these choices, and if you don't, then something is wrong. So, by the way, this applies even to clustered data or longitudinal data or any other kind of multi-level data where you'd have a random intercept. When I fit these sorts of models on that type of data, I take the random intercept out, because then if you leave it in, they won't match.
Okay.
So it has to be truly empty, nothing in the model but a single set of fixed intercepts, one for each submodel. So the model with respect to the intercepts and the slopes, those are operating within each submodel as if those are the only two possibilities.
So
But
to your point, that's then the frequency of whatever it is over the sum of the percentages of just those two.
of just
numbers.
those two, exactly.
Okay.
So this logit of 0.45 means, given that you answered either 0 or 1, this is the logit of picking 0 instead of 1, because 1 is my reference. Likewise, this logit of minus 1.2 is, given that you chose 1 or 2, this is the logit of choosing 2 instead of 1. So then the predicted probabilities are bringing back in the answer choices that were ignored to become marginal rather than conditional. And the same exact thing happens in Stata when you do margins. Stata's margins just spit back the three probabilities. What is the probability of the first category, the second category, and the third category, which is actually 0, 1, 2. So even though its coefficients are exactly the same, and the way that Stata's output is organized, I think, is very handy, because it has this middle row here that tells you what your baseline is, to remind you. So 1 is the choice. So the logit of picking 0 instead of 1 is 0.45. The logit of picking 2 instead of 1 is minus 1.2. And then R, same answers, but it just labels them in the order of which submodel is which. So I had to add this commentary, this is for picking 0 instead of 1, and this is for picking 2 instead of 1. So the name of the linear predictor here that it's describing is, like, this is conditional, right? It's only these 2 answer choices or only these 2 answer choices, but it's not the actual answer. It's the first choice, the second choice, and the third choice, according to R. And it tells you that the reference group is level 2 of the response, which corresponds to an answer of 1. So in your next homework that you get a chance to practice these models, there are a whole bunch of questions as to what the model is even predicting. Like, that's a drop-down answer. Because keeping this straight is non-trivial. Like, there's going to be no interaction terms. There's no predicted probabilities. There are odds ratios, because that one gets spit out for you. But like the linear model side of it is going to be the simplest thing you can think of. It's all about what is y. Because keeping this straight across models and across submodels is challenging. And I acknowledge that's a sufficient challenge for one homework assignment. And so then in R, I went ahead and wrote code to flip those logits to probabilities and verified that, yes, R is working the same way with respect to that. Okay. So any questions on the basic idea here of what we're trying to do, or the syntax by which we try to do it? Okay. Zoomers? Doing okay? All right. So let's throw some main effects in here. So I am writing out what the model is predicting to convey the idea of this conditionality. Given that you chose 0 or 1, the model is predicting the logit of 0 instead of 1. Given that you chose 2 or 1, the model is predicting the logit of a 2 instead. And note that I added subscripts that match what was being predicted, because I thought that that was the most intuitive way to describe it. So as a general rule, when you are creating a system of notation, you do not have to follow necessarily how other people do things. Like the second submodel, I could have called this like model 1 and model 2, but I picked 0 and 2 because that's what I'm predicting. Same thing with the subscripts. You don't have to have I, J, K on everything. You can pick letters that actually match what the subscript refers to, and in fact, that will help your reader quite a bit. So in these equations, I have subscripts for which predictor and which submodel, because in these nominal models, everything is estimated separately by default. That's the only thing that would really make sense, because these categories don't have any inherent ordering to them. So there's no reason why you would expect the effect to be the same of a predictor across submodels. So in SAS, I throw in the same 3 predictors that we've been looking at: GPA, whether your parent has a graduate degree, and whether you went to a private university. And I have, in this case, a chi-square for those 3 terms. But how many degrees of freedom would this chi-square test be? And don't say 3. It looks like 3. But it's not 3. How many slopes does GPA 3 have in this model?
2.
2.
So it's 6.
6. Yeah. So even though you're only referring to one of them, it's the number of slopes total for that predictor that goes into these tests. So if I had a 4-category outcome requiring 3 submodels, then I would have 9 slopes in total. 1 for each submodel.
Can I ask,
Go for it.
just kind of a theoretical or overarching question? So, is it true, I guess, like, differentiating between, like, when to use non-proportional versus proportional odds, because data that's not naturally ordered, you know, where we might be interested in looking at it in a non-proportional odds model kind of situation. I mean, should that just be something that you should always go to, even if it seems like something is naturally ordered, like rating on a survey, like a Likert scale or something like that, just to double check that things are actually equal? I know that that sample size and power is kind of at play as well, but I guess I'm speaking more generally.
So I would say that if you truly have a nominal outcome, then nothing in the proportional odds ordinal family would make any kind of sense for that. Because each of those submodels, even if you have separate slopes across submodels, each submodel is cumulative and it lumps choices together. So the lumping together is problematic if it's not ordered in a way that makes sense.
I think I said that backwards. So like if you have something that seems ordinal, like a Likert scale, or
Yeah.
would you want to test to see if slopes across submodels are actually different as a first step?
I would.
Okay.
Yeah, I think that's a reasonable thing to do. Keeping in mind that your power for the test has to do with how many people are in each category and all that kind of stuff. So these models, relative to the others, like the default setting of these models, they're the most parameter intense because all slopes are estimated separately for every submodel, all intercepts are separate. So you need the most data to do something like this. So I went ahead and wrote out predicted logits and probabilities here just as a demonstration of how to do that. And then here are the parameter estimates. So the way that SAS has listed these is by term. So I've got my 2 sets of intercepts, my 2 sets of slopes for GPA, my 2 sets of slopes for parent degree, and so forth. So then what's that number? 0.9515. It's a logit. It's an expected logit for something when something is true. They're filling in the holes in the sentence for you.
Right, like the in-part class now becomes Mad Libs.
Yes, this is in-class Mad Libs. I'm giving you where the drop downs are. This is a logit of something. Yep. The logit of apply of 0 instead of 1. When all the predictors are 0. So for the reference person for this model, the logit of saying nope instead of 1 is this 0.95. Good. How about this one? Logit of minus 0.76.
This is still, this is 2 compared to 1 now,
2 compared to 1.
when the rest of your predictors are 0.
When the rest of your predictors are 0, exactly. And so then our effects of GPA, interestingly, are almost identical. But they're backwards because of the way that I've set up the coding. So people with a higher GPA are less likely to pick 0 instead of 1. And they are more likely to pick 2 instead of 1.
So you did a different coding scheme where it was 0 compared to 1 and then 1 compared to 2.
Yeah.
Those would be roughly same magnitude and
Yep.
same direction.
They would be exactly the same, but the magnitude would switch. Exactly. So this is essentially what I've done here is an adjacent category model of 0 versus 1 and 1 versus 2, except the first one is backwards.
Got it.
So yeah, so I'll say that again. People with a higher GPA are less likely to say, nope, not going to grad school instead of maybe. But they're more likely to say, yes, I'm going to grad school instead of maybe. So either way, people with a higher GPA have a higher predicted response. They're higher up in the probability of going to grad school. The only one of these that's actually significant I have in bold here, if your parents have a graduate degree, you are less likely to pick no than 1. Pick 0 than 1. And you are more likely to pick 2 instead of 1, but not significantly. So private school is the only one that's surprising because these are both negative, and you'd think that one of them would be positive, given the difference in the coding. But one other thing that SAS spits out, which is handy, is a combined test. So this is there an effective GPA across submodels, lumping the two slopes together? And the answer is no. Note that this is labeled as an F because that's what Glimmix provides, but without denominator degrees of freedom, it's actually what? Chi-square. There we go. Yes. So it does that for both of the slopes. Then we got odds ratios. At least that's what SAS calls them. So let me find, where's the code? Yep, so I added the odds ratio command that got me those additional odds ratios. And then here are the predicted logits for different kinds of people that you could make a plot out of. And indeed I did. I think that's either in the Excel sheet or still coming. So. And it does the predicted logit by category. So it spits out both of them. I only had to write one line. And the same thing is true with these probabilities out here. They do not match. So this is a conditional logit, but this is a marginal probability. Okay.
I have a question about those.
Hit me.
So in the predicted outcomes with the marginal probability, I think this is a basic question, but when you say like the probability, the marginal probability is like that very last number there, 0.269, 0.27, is another way to say that like there's a, is it wrong to say there's a 27% chance and then describe it and the rest of it? Is that like the wrong way to talk about a probability?
That might be too informal, but I'm inclined to say that's okay. Like that seems like it should be close enough. But it's not a rate. It's not an odds ratio or anything like that. So like for this kind of person who went to private college, whose parents have a graduate degree and they got a 4.0, then the probability of them picking 2 is 0.27. The end.
But it's not that 20% of those people picked a 2 rather than a 1?
It's not. That's what the logit is. The logit is talking about if you picked 1 or 2, what's the logit picking 2? But this is the marginal probability lumping in the zeros again.
Okay, so really the only way to talk about that, those probabilities is the probability is and then a number.
Yep. The probability of answering 2 is this number. The probability of answering 0 is this number. And then the difference relative to a sum of 1 would be the probability of a 1. So if we look at this data output, we can see that a little more directly. Did I put these in here? Yeah, so like Stata gives you the probability of, let's see, there's probability of for each of the cases. So like that is the probability, this one is the number that we just looked at. The probability of answering 2 for that person is 0.27. The probability of answering, oh goodness, where did it go? A 1 is 0.22, so that matches what SAS is telling us for that one. And then the difference, whatever's left, is in the middle category, which is right here. So it just tells you flat out, if you're this kind of person, this is your chance of getting a 1, this is your chance of getting a 2, and this is your chance of getting a 0. So I'm inclined to agree with your language, Andrea. This is your chance, but there's probably a mathematician listening on YouTube right now shuddering because I'm describing it incorrectly. But they're probabilities.
Next time you teach this class, then you can get it right.
I know, I'll get it right then. Stay tuned, 2 years from now, I'll screw this up less. Yes, sir.
So is this considered multivariate regression?
No.
Okay, so there's not multiple outcomes that were,
It's one outcome.
it's still one outcome.
It's still one outcome. Because what if you were to predict two nominal outcomes simultaneously,
Oh,
and then each would have their own submodels, and that would be multivariate nominal regression.
okay. Are we going to get to that in this class, or is that a different class?
We're going to get to something resembling that. We're getting to multivariate models. I don't know that I have a nominal example, but you can do it in a path model setting pretty straightforwardly. It's the building of the submodels that takes the conceptual leap. Once you know how to build a submodel for one outcome, you can do it for as many as you want. Figuring out how to do it in software is also sometimes tricky, but path models are the most direct way to do multivariate models, I think.
So the submodels, like, each predicts one outcome, but it's just different levels of an outcome, or different categories of an outcome, but they're each treated singularly.
Yeah, I would still say it's one outcome.
Okay,
It just takes multiple equations worth of parameters to do it.
okay.
Yep, tricky stuff. So in the Stata book, they insist that these are not odds ratios. They are relative risk ratios, but the numbers are the same. So I don't care what you call them. Each of the logit is this thing that's used as an effect size. So I added, relative to the SAS code, this is the test statement that matches the contrast right here to get a joint test of the overall model. In Stata, you have to refer to which submodel it is with the thing that's being predicted in brackets. So this is all 6 slopes for that model, 2 submodels worth. And as usual, predict XB gives you logits, and if you take that off, you can get a range of predicted probabilities across levels of your covariates. And then I did the same model with RRR for relative risk ratio, which is the odds ratio version. So the author of your textbook, what is it, Hilby and the other guy, Henderson's? That's not right. I don't know. The textbook we have for this class, the Stata book, they were like, no, it's not an odds ratio. Are you sure? Because the number's the same. So, whatever. Predicted probabilities, and then, yeah, they labeled them RRR. So they have doubled down that it's not an odds ratio. Okay. That to me sounds like Huey refusing to eat his dinner because he wants snack instead. I'm like, okay, do you want a hamburger for snack? Yeah. All right then. Let's go have snack. Call it good. And R. Let's see, where am I in the R world here? Okay, so I got the odds ratios the usual way by going into the coefficients and then exponentiating them. And GLHT, this one actually worked. So the results of this test for all 6 slopes did match that of the other programs, but I'm not taking any chances and not asking for that in your homework. And then I used the predict function to get predicted logits, and then type equals response is inverse link for predicted probabilities. And then I renamed the columns because the name that they gave them was ridiculously long and unhelpful. So then the results match exactly what the other programs spit back. This is the way that SAS organizes it by term. And then the first submodel, you just have to know that that's predicting a 0 instead of a 1. And the second submodel is predicting a 2 instead of a 1. And otherwise, everything works about the same. And here are the odds ratios or relative risk ratios, the multivariate test, which is correct. And then these are the predicted logits and predicted probabilities that predict function gave me. And yes, I thought I had made a picture. So one thing that I haven't figured out, and to be honest, I haven't looked all that hard, is to try and find a way to test whether or not the slopes differ across submodels. Like, is GPA more important in predicting a 2 than it is in predicting a 0? Like a question like that. I haven't seen much of that, but it seems like that should be possible to do. I just don't have that figured out yet because I've never needed to. And that's the end of that story. So the last paragraph then describes the results that we just went over. And we're finished. Finally. What do you think? Could you do this in real life? If you had to?
I hope so, because I have a project that will probably use it.
Ah.
That's going to be coming up soon.
So you have a project that will use it. That is the best way to learn something. I'm telling each of you, if you have like discretionary time, find a data set that matches what you're learning and try to do things to it, because there's something magical that happens when you have to translate the material into something that you care about the answers. That kind of magic cannot be replicated by in-classroom experiences. And it's also a really good way to build your publication history, is to get into people's projects after they have the data, help them analyze the data, and help them write it up. So, highly recommend. Okay, any questions on categorical outcomes models before we change gears then? Going once, going twice.